Okay, so we're looking at question 8 of the 2013 exam. So by introducing slack variables and artificial variables as appropriate, and using the two-phase method, we aim to write down the first tableau of the simplex algorithm of the following LP problem given here, and we write our answers in this tableau provided. And finally, we have to circle the entry that we'll pivot on. Okay, so to make sure we don't forget this, I'll just underline this one here, a couple of exclamation marks, just because it's very easy to forget this after you've done the bulk of the work and you've filled out all of this table. But really, this part of the question should be fairly straightforward and free marks in the end if you know what you're doing. Okay, so firstly, we aim to get our constraints given here into the appropriate form so we can write them into our tableau here. So firstly, we aim to get these numbers here on the right hand side of these signs to be non-negative. So we have to fix up this first constraint here by multiplying this inequality by -1. So let's do that quickly. So we have minus x plus 3y minus 7z is greater than or equal to 3. Now we have non-negative numbers here. We can now get rid of these two greater than or equal to signs and make them into equal signs by introducing slack variables and artificial variables. Okay, so this first constraint, because we do have greater than or equal to signs here, for both of these constraints we will need to introduce a slack variable and an artificial variable. So in this first constraint, let's rewrite this now. So we've got minus x plus 3y minus 7z and minus our first slack variable, which we'll call s1, and then adding our first artificial variable, which we'll call r1, and then writing equals 3. And for our second constraint, we have y plus 4z, again minus our second slack variable, s2, and plus r2, our second artificial variable, and that equals to 2. Okay, so now to set up the first phase of this two-phase method for this problem, we give ourselves a maximization problem, and we aim to maximize some variable w, which we make equal to minus r1 minus r2, and that's because in this first phase of the problem we aim to get rid of these artificial variables and then deal with the slack variables in the second phase. So now we can rewrite what w is by substituting r1 and r2 in here. So that gives us minus x, and now we have plus 3y plus y equals plus 4y, minus 7z plus 4z equals minus 3z, minus s1 minus s2, and then minus 3 minus 2 equals minus 5. Okay, so now we can start putting entries into this tableau. Okay, so firstly we'll write in all the variables we need. Okay, so firstly we'll use this first constraint to write in the first row of our tableau. So we look at the coefficients in front of each of these variables. So we have minus 1 for x, 3, minus 7, minus 1, 0, 1, 0, and 3 at the end there. And now our second constraint, we have 0 for x, 1 for y, 4 for z, 0, minus 1 there, 0, 1, and 2. Okay, so now for this Q row here, we flip the signs for the coefficients in front of here. So that gives us 1, 1, minus 1, and then zeros for the rest. Okay, so now we can see that R1 is the basic variable for this one, R2 is a basic variable here. Okay, so to complete this final W row, the way I do it is to firstly notice that we have W equals minus R1 minus R2, which also equals minus R1 plus R2. And from this, what we can do is add up these two numbers here, and then their value we put into this entry here is that number multiplied by minus 1. So we have minus 1 plus 0 equals minus 1, multiplied by minus 1 gives us 1. And same here. And same again for this entry here, we have 3 plus 1 multiplied by minus 1 equals minus 4. Okay, so we have minus 3 here, multiplied by minus 1 is 3. Minus 1 multiplied by minus 1 gives 1, same as here. And then minus 1 for these two. And then 3 plus 2 equals 5, multiplied by minus 1 equals minus 5. And that's one way of doing the W row. Another way is to take the negative coefficients in front of these guys, and then this coefficient, as it's not in front of any other variable, we don't change the sign of that one. Okay, so we've finished our tableau. And finally, we come back to this one up here, and to find the entry that we pivot on, we first look at the biggest negative number in our W row, which is negative 4 in this case. And we look at the smallest non-negative ratio out of 3 on 3 and 2 on 1. And because 1 is less than 2, we pivot on this element here. Okay, and we've finished this question.